In this video, we'll show how to find the Maclaurin series using the definition of a Maclaurin series for a given function. So first of all, let me remind you what Maclaurin series is. If we assume that such series exists, then it can be determined by this formula. So in order for us to find the series, we just have to compute each coefficient. And the best way is to organize the work in the following format. We're going to have the table, and for each n, we're going to take the nth derivative of the function. Then we're going to evaluate the nth derivative at 0. And then we're going to divide that by n factorial, and that will be our nth coefficient. So first let's start with the n equals 0. So here we just have our function itself, and the function itself evaluated at 0 is just 1. So 1 divided by 0 factorial is just 1. When n equals 1, we find the first derivative. The first derivative is negative 2 e to the negative 2x. So evaluating it at 0 gives us negative 2, and we take negative 2 and dividing it by 1 factorial, which is negative 2. So when n equals 2, we find another derivative. So now it's 4 e to the negative 2x. So the value of the derivative at 0 is 4. Dividing 4 by 2 factorial gives us 2. At 3, the third derivative is negative 8 e to the negative 2x. So the derivative evaluated at 0 is negative 8. So the coefficient will be negative 8 divided by 3 factorial, which is negative 4/3. And now we probably want to start looking for the pattern here. If I take the nth derivative, it seems like the nth derivative will be equal to negative 2 to the power n e to the negative 2x. And evaluating it at 0 will just give us negative 2 to the power n. And dividing it by n factorial will give us negative 2 to the n over n factorial. Therefore, e to the negative 2x can be expanded as this negative 2 to the n over n factorial times x to the power n. Now, to find the radius of convergence of this series, we're going to use the ratio test. And the ratio test says that the series converges when the limit as n goes to infinity of the n plus 1th term over nth term is less than 1. Now, absolute value of x can be factored outside of the limit, and what's left in the limit is 2 over n plus 1. 2 over n plus 1, when n goes to infinity, goes to 0. Therefore, absolute value of x times 0 is less than 1. And the question is for which values of x this is true. And anything times 0 is 0. Therefore, x could be any number between negative infinity and infinity. So in this exercise, we found the Maclaurin series for a given function, and we determine its radius of convergence, which is infinity.